So my problem here is when a 4 kilogram mass is hung vertically on a certain light spring that obeys Hooke's law, the spring stretches 2.5 centimeters. If the 4 kilogram mass is removed, A, how far will the spring stretch if a 15 kilogram mass is hung on it? And B, how much work must an external agent do to stretch the same spring 4 centimeters from its unstretched position? So we know that the first thing I did was I drew a diagram of what's going on. That's the spring. All right, so we know that the force the spring exerts on you is in the upward direction, and then the force that you exert on the spring is in the downward direction. So the first problem, A, is wondering how far will the spring stretch if a 15 kilogram mass is hung on it. And I started off by using this. I did F is equal to negative kx. And so then we go to F is equal to negative mg, and I plugged in my values for that, and I get it is 39.2 newtons, negative 39.2 newtons. And then I get K is equal to F divided by X. I plug in my values for that, and I get 1,568 newtons per meter. And then use the X is equal to negative F divided by K to find a displacement of 1.5 kilogram mass. So I use the equation as F to equal to negative 1.5 kilograms times 9.8 meters per second squared. And I got that out to be negative 14.7 newtons. And then from there I use X is equal to 14.7 newtons divided by 1,568 newtons per meter. And I get that out to be 0.009375 meters, or I got 0.975 centimeters. And then for part B, it was asking how much work must an external agent do to stretch the same spring 4 centimeters from its unstretched position. And to figure that out, we used the work formula, and all I did was I plugged in it's W, which equals 1/2 kx squared. I plugged my values in, and it equaled to 1.2544 newtons per minute, which equaled to 1.2544 joules.